Alright, ladies, this is your practice quiz review for trigonometry. This is what your Math Excel quiz will look like, obviously with different problems. Sorry about my printer, it's not working fully, so some of these are cut off, but I'll do my best to read them off to you. So let's get started. Okay, so find a positive angle less than 360 degrees that is coterminal with the given angle. 545 degrees is the given angle. And so to find our coterminal angle, we just need to subtract 360 degrees from 545. And that leaves us with 185 degrees. That is less than 360, and it is positive. So there we go. That's our coterminal angle. Do another one. Find the measure of an angle between 0 and 360, coterminal with negative 420. Now, whenever you have a negative angle, instead of subtracting 360, we're going to add 360. So when we add 360 to negative 420, you get negative 60. But the problem with this is it's not between 0 and 360. So what we want to do again is add another 360 degrees, right? The goal is to get between 0 and 360. So we just add 360 one more time, and that gets us to 300. And that is our angle between 0 and 360, so 300 degrees. Okay, same thing here, right? Less than 360, positive angle less than 360, negative 295. We're just going to add 360 because the angle is negative. So negative 295 plus 360 gives us 65 degrees. And there's your coterminal angle. Okay, here, find the exact values of cosine and sine of the angle. Then find the decimal values. So exact values means we need that unit circle. So I did not prepare myself, and I don't have a unit circle ready, so let me look one up real quick. So if we're looking at the unit circle, just look for 150 degrees on the unit circle. Hold on, sorry here. So when you look at 150 degrees on the unit circle, the cosine is, remember, this is the x coordinate, okay? So the x coordinate at 150 is negative root 3 over 2. And then the y coordinate at sine of 150 is 1/2. And then to find the decimal, we can just punch it in our calculator. Cosine of 150 is negative, and it's rounding to the nearest hundred. So make sure you're paying attention to how they ask you to round. Okay, make sure you're paying attention to how they ask you to round. Cosine is going to be to the nearest hundred, so negative 0.87. And sine of 150 should just be 0.5, right? That's 1/2. Okay? So again, here I use the unit circle. And I look for the angle 150 on my unit circle, and then my x coordinate is negative root 3 over 2. The y coordinate is 1/2. And then here I can just use your calculator to punch in and find the decimal values. All right? Okay. Next, convert the following degree measure to radian measures. So to convert from degrees to radians, we're going to multiply by pi over 180. So this looks like 135 pi over 180. And we just want to reduce that as much as we can, right? Type in integer or fraction here. So don't give it a decimal answer. We want this in pi. So this would reduce, you could punch this in your calculator too to reduce it. And this would reduce to 3 pi over 4. Make sure when you punch this into the computer that 3 pi is in parentheses, just to make sure that it's, all in the denominator. Okay, here, convert 2 degree measure. 6 pi over 11. So I'll write it a little bigger. 6 pi over 11. We're going to multiply in order to convert from radians to degrees. We're going to multiply by 180 over pi. Right? So the pi's will cancel out. You have 6 times 180 over 11. And then that leaves us with 1080 over 11. But it says round to 2 decimal places. And so let's see, what does that give us? Oh, geez Louise. 98.18. So 98.18 degrees. Okay? This bottom one, convert the following radian measure to degree measure again. So again, it's negative pi over 4 times 180 over pi. Okay, pi's again will cancel. Negative 180 over 4 is negative 45. Okay, it says do not round to the final answer, then round to the nearest hundredth. But obviously we don't need to round that any further. So that's negative 45 degrees. Okay. All right, moving on. It says here, the measure theta of an angle in standard position is given. Find the exact values of cosine and sine for the angle measured. 2 pi over 3. Okay, so here we're going to go back to the unit circle. They want exact values, so we're just going to use those coordinates, right? So if we look at sine of 2 pi over 3, this is equal to negative 1/2. And sine, sorry, that's cosine. Cosine, remember, that's the x coordinate. Sine is the y coordinate. 2 pi over 3, that's root 3 over 2. Okay, again, looking right at the unit circle. Here's another one. Okay, find the measure of the angle in the standard position. Find the exact values of cosine and sine. 7 pi over 4, again, right to the unit circle. Okay, they were asking for exact values, so we just have to give them what they want on the unit circle. The x coordinate at 7 pi over 4 is root 2 over 2. The y coordinate at 7 pi over 4 is negative root 2 over 2. Okay. Find the length x. Moving on. Find the length x of this triangle. We're given the angle. Okay, that's A. Here's B and C. We're given the angle. We're given the little side A. And then we're asked to find x. This is 38. If you can't see it, the angle here is 39 degrees. Right? So what are we given? We have an angle. We have the opposite side of the angle. And we're asked to find the adjacent side, right? So opposite and adjacent, that should be tan, right? Tan theta is opposite over adjacent. And so here we could say tan of 39 equals 38 over x. And if we rearrange the equation for x, it's going to be x equals 38 divided by tan of 39. And 38 divided by tan of 39 is 46. What does it say? Round to the nearest tenth. 46.9. Okay. Make sure you are in degree mode. Calculator in degree mode. Okay, because you're given the angle in degrees, so the calculator needs to be in degree mode. 38 divided by tan 39 is 46.9. Okay, find the 6 trigonometric values for the angle in standard position determined by the point negative 12, negative 5. It's negative 12, negative 5. So remember here, we want to first, we're just going to plot these points. Right, so here's negative 12, let's say. Here's negative 5. Okay, there's the point they're discussing. We're going to draw a triangle straight to the x-axis and to the origin. So that's our right triangle. This height of the triangle is negative 5. The base of the triangle here is negative 12. So we need to find the radius in order to find all of these tangents, okay? So let's do that. How do we do that? R squared equals the square root, R squared equals -5 squared plus -12 squared. So R squared equals 25 plus 144. So R squared equals 169. And the square root of 169 is 13. So R equals 13. So now we just use SOHCAHTOA, right? And then the inverse. So sine is, and we're talking about this angle here too, right? So that's the angle we're discussing. So sine is opposite over hypotenuse, so -5 over 13. Cosine is adjacent over hypotenuse, so -12 over 13. Tangent, opposite over adjacent. Opposite over adjacent, -5 over -12. And so that leaves us with +5 over 12. Cosecant is the inverse of sine. So we could just flip the sign, so that's going to be -13 over 5. Secant is the inverse of cosine, so we just flip cosine, so that's -13 over 12. And then cotangent is the inverse of tangent, so we just flip that one, so that's 12 over 5. Okay? Here, again, we want to find each value. Sine of A, secant of A, cotangent of A, cosecant of B, secant of B, and tangent of B. Alright, so let's look at sine of A. So first, here's A is up here, there's B and C. This is 42, this is 58, this is 40, just because I know it's hard to see. So let's take a look. So for first talking about sine of A, we're looking at opposite over hypotenuse, right? Sine is opposite over hypotenuse, so that's 40 over 58. And if we reduce that, let's see, what does that give us? 20 over 29, and that is the reduced simplified fraction, 20 over 29. Secant of A. Now secant is the opposite of cosine, right? So we don't have cosine yet, so we actually can find cosine A first, which is adjacent over hypotenuse, so 42 over 58, which is 21 over 29. And then the secant of A is the inverse of that, so this is 29 over 21. Cotangent of A is going to be the opposite of tangent of A. So if tangent of A is opposite over adjacent, so 40 over 42, and if we reduce that, we get 20 over 21. But cotan is the inverse of that, so it's 21 over 20. Alright, cosecant of B. Cosecant is the opposite of sine. So if we do sine B, which is, here's B now, right? We're looking at 42 over opposite. Sine B is opposite over adjacent, so 42 over 58. Which you actually see up here is 21 over 29. But cosecant is the opposite of sine, so this is 29 over 21. Secant of B is the opposite of B, so if we look at cosine B is going to be 40 over 58, which reduces to 20 over 29. And so then the opposite or the inverse would be 29 over 20. That's your secant B. Is 29 over 20, the inverse of cosine. And then finally, tangent B, that's easy. That's just opposite over adjacent. So it's going to be 42 over 40. Opposite over adjacent, which is 21 over 20. Okay? And that's all 6 for that triangle. So again, real quick. These are the originals they were asking us for a lot of the inverses, so I found the original first and then the inverse. You could also just, find the inverse as well. Okay? All right, next. It says here in triangle, GHI, angle H is a right triangle, GH is 3, cosine G is 3/5. Draw a diagram and find the values of the parts. So let's see. Which of these, we're looking at H is the right angle. Cosine, remember, is, again, adjacent over hypotenuse. So we're going to look for the adjacent side to be 3 and the hypotenuse to be 5. Right? So if angle H is the right angle, GH is 3, so here 3 and 3, so it's really these two options. But we want the hypotenuse to be 5, so that's going to be A. Right? There's the 3, there's the 5, H is the right angle, there's G, and there's I. GHI, 3/5. So now we can use this triangle to find sine of G in fraction form and in decimal form. So sine of G, so first actually, let's find the other side here. If we use Pythagorean theorem, and we find the third side, it's going to be equal to 4. Right? So just in case you're not sure, I'll do it anyway. So this is going to be what? 5 squared equals 3 squared plus, let's just call it G, little g squared. Right? That's 25 equals 9 plus little g squared. So 16 equals g squared. So 4 equals g. Right? So that's how you can find the length of that side. So that's going to help us. So sine of G is opposite 4 over hypotenuse, 5. So 4/5, that's the first one right here. Part B says find sine of I. Okay, find sine of I. And that's going to be, again, opposite over adjacent of I. So what's the opposite of I? Well, that's 3. And the hypotenuse, I meant to say, not adjacent. Opposite over hypotenuse, right? So 3/5, so sine of I is going to be 3/5. So that again here is the first one, which is a little cut off. Okay? I'm not sure what that number is right there, but it should be sine of 3/5. Yeah. Okay? Moving on, find cotangent of G. Okay, so cotangent of G, cotan here, we'll do it a quick way. If tangent is opposite over adjacent, then cotangent is adjacent over opposite, right? So if we look at adjacent to G is 3, opposite to G is 4, so this is going to be 3 over 4, which is C right there. And then finally, cosecant. Okay, cosecant, which is the opposite of sine. So if we look at cosecant of G, sine is opposite over hypotenuse. So cosecant would be hypotenuse over the opposite side. And so that's going to be 5 over 4. And here it is, 5 over 4. Okay, moving on. Oh, we still have a couple more parts to this problem. Now it's asking us for, let me keep the triangle here then. It's asking us for cosine of I. Okay, so cosine of I is what? Adjacent over hypotenuse, 4 over 5. 4 over 5. Cosine of I, 4 over 5. And the last one here, find secant of H. Secant of H. Now the problem with this one is that, let's see, secant is usually the opposite of cosine, so it would be hypotenuse over adjacent. But the problem here is we have a right triangle and H is actually the right angle. So hypotenuse, and then you say adjacent, but which side would you choose, right? I mean, they're both technically adjacent, and the hypotenuse is the opposite. So here, because H is a right angle of the triangle, you cannot find its sine or cosine or secant, right? Or tangent or cotangent. H is the right triangle, or sorry, the right angle of the triangle, and so you cannot find those trig values, okay? You cannot find the trig values, any of them, okay? Let's do another one. Find length x, number 15 here. This is 20, by the way. This is 39. Here's B, C. That's side x. Alright, so again, what are we given? We're given an angle. We're given the opposite of that angle, side of that angle, and the adjacent. So that's just tangent, like the other one we just did earlier. Right? So this is tan 39 equals 20 over x. And so x would be 20 over tan of 39 after solving that for x. Round to the nearest tenth, so 20 divided by tan of 39 is 24. Rounding to the nearest tenth, 24.7. Okay? Here, number 16, in triangle ABC, angle C is the right angle. Find the remaining side and angles. So B is 12 and C is 13. So let's draw this triangle. C is the right angle. Okay, so we're going to do A, B, C. B is 12, that's this side. C is 13, that's this side, the hypotenuse. And so we have to find the third side. So the side angle A we can use by finding Pythagorean theorem, right? 13 squared equals 12 squared plus A squared. When you solve that, you're going to get A equals 5. Alright? This is also a special right triangle. This is called a Pythagorean triple. 5, 12, 13, any multiple of these, but don't worry about that. That's just a side note. Alright, measure of angle A. So how can we find the measure of angle A? Well, we can use any of the trig functions. We could do sine, tangent, or whatever. So we can do sine of A equals 5 over 13. And then A, remember, here's where we're going to use inverse sine. A is equal to the sine inverse of 5 over 13. So sine inverse of 5 over 13 is 22, and then rounding to the nearest tenth. So 22.6. Okay? And measure of angle B, we can do basically the same thing. We can do sine of B equals 12 over 13. And so B equals sine inverse of 12 over 13. So sine inverse of 12 over 13 is 67.4 rounded to the nearest tenth. Pay attention to how those instructions there, ladies, okay? Alright. Oops. Here's another triangle. Okay, we want to find the remaining side and angles again. So B is 1.5. That's this side here. C is 3.7. And so we need to find A first. So we're going to use Pythagorean theorem, right? 3.7 squared equals 1.5 squared plus A squared. So I'm going to skip a few steps here. So this is 11.44 equals A squared. And if we take the square root of that, we get, rounded to the nearest tenth, we get 3.4 equals A. 3.4. Alright, so that's this, 3.4. Okay, so for measure of angle A. So for the measure of angle A and B, I'm going to use the given side lengths. Because we rounded to find this third side length A, I don't want to use that because it's really picky. So let's use the given side lengths, right? That way we know for sure that the side lengths work. So let's see, measure of angle A, I'm going to use cosine. So I can do adjacent over hypotenuse. So cosine of A equals the adjacent side, 1.5 over 3.7. And so A is cosine inverse of 1.5 over 3.7. Sorry, a little messy there. So cosine inverse of 1.5 divided by 3.7 is 66. Again, we're rounding to the nearest tenth, so 66.1. And then we want b. I'm going to do sine of b, so I can do the opposite over adjacent. So sine of b equals the opposite over adjacent. So it's actually the same two sides. B is equal to sine inverse of 1.5 over 3.7. So sine inverse of 1.5 over 3.7, whoops, is 23.9. Right, again, rounded to the nearest 10. Okay? All right, one more. Find the exact values of cosine and sine of the angle. Then find the decimal values. Okay, so here we can use the unit circle again for the exact values. Okay, for the exact values, use the unit circle. At 135, the cosine is our x-coordinate, which is at 135, negative root 2 over 2. And for y, sine of 135 is positive root 2 over 2. And then here we're going to use our calculator to find the decimal values, right? So cosine of 135 is negative 0. What are we rounding to? The hundredths place. So it's 0.71. Okay? And sine of 135 is positive 0.71. And that is it, ladies. Okay? So if you have any questions, let me know. Over the weekend, email me. If you want to meet on Monday, you need a video chat or something, some extra help, let me know. I'll be there. I'll be available. All right? Take care. Have a great weekend. Adios.